Hello, welcome to Chris Khan Academy, the YouTube channel, which brings you about mathematics and biology. Now we are going to discuss about mathematics on the point called inner product on the complex number. This is excited education. It is very interested on this YouTube channel, Chris Khan Academy. Make subscribe, comment, share, and like, such that each and every video that we would like to upload on this channel, you have to be ready to watch it. So we are going to start on the definition of inner products on the part of the complex number. This is the one of the part of algebraic multilinear. So this is the function where we are going to see how we can convert or how can we fix the two functions that go in the one formula and how we can find that. And then this is in part of the complex. So here we will find that we have the real part of the function and the f2x and the g of x, or the function g is equal to g1 x plus I g x are the vectors. So these are it's the supposition in the complex. So then we have the point C, which have A and B. Therefore, the following formula are extracted by the way, or defines what an inner product in the part of the what, in the part of the complex. So I would like to invite, just watch, be ready and attentive. We are going to formulate this formula F, general F capital letter and general G capital letter, which comprises F1 and F2 and G1 and G2. So for both, they have a imaginary part and they have a real part. So in the inner products, in the linear multilinear algebra, we like to formulate this formula as follows. So Fg, inner product of Fg is equal to integral from A to B, as the interval we have given as the C, of f1x, then plus I f1 of A to B times g of 1x and my plus ig2 of x, but that part of g1x plus igx is the in part of what, conjugate. You have to conjugate that part, g1x plus I. This is the inner product of the complex with a given fixed point A and B. This will be equal to integral AB plus if2x times g1x minus I g2x bracket dx. The y you put there minus, we say that g1x plus I g2x, it is in a conjugate. If we conjugate this, we get, instead of getting plus, or instead of getting g1x plus ig2x, we have to write g1x minus, because we conjugate plus, then transformed into minus. So ig2x dx. So this will be implies that integral from A to B f1x times g1x plus f2x times g2x dx. So then plus, this is the part of the real part, f1x times g1 complex. This is integral from a to b, f of 2x dx, f of 2x and g1 2x minus f1x and g2x times d dx. I'd like to invite you also to make you remember that we are formulating the inner product of the complex number in an appropriate interval a, b. How we can work out this? So we are going to use examples. So this is a general formula of what? Of introducing about the inner product of the complex number. But on the set of an interval a, b, let us work out or go through with what? With an example. So we have the question which states that if f of x is equal to 2 plus I sine x and g of x is equal to 3 minus I x, evaluate the inner product of fg over the given appropriate interval, which is the 3 and 2 pi. So we have the question. We said if f of x is equal to 2 plus I sine x and g of x is equal to 3 minus I x, then we are asked to evaluate the inner product over the interval of 3 to pi. Let us see the solution. I think you have to go back to the formulated formula we do, then we memorize it, and then we demonstrate that formula so that we can help us, or it can help us to do this question. Let's go ahead. Here, the inner product of fg, as we said, is equal to integral from a to b bracket f1x plus if2x general bracket the gx g1x, so plus I g2x in general dx. So, and that part of g1x plus I g2x dx, it is what we call the conjugate, and then the inner product will become to a we know that is 3, sorry, it is not 2, it is 3, yes. B, it is equal to 2 pi. Then we have f1x, it is equal to 2 plus I sine x plus I f2x. Then we have to multiply there the conjugate of gx, g1x. So we don't have f2 and we don't have g2. That's why we take f1x plus g1x, then g1 and can be the part of the imaginary and the f1 can be the real part. So this will be equal to integral from 3 to 2 pi plus I sin x bracket 3 plus I x then dx. So let us see the next step. Following step by step about this question. I think each and everything is understandable at this age. What you have to know, it is the formula just. So now let us continue to the next stage, and the integral of 6 minus x sine x with the bracket plus I 2x plus 3 sine x, and we put the correct together the imaginary parts on the side and the real parts on the other side. So this 6x integration of 6 is 6x plus, if you say the integration of sine x sine x will be equal to instead of my saying minus, it is plus cosine x, then plus minus sine x. X sine x is equal to x cosine x, see? Minus sine x with respect to our interval 3 to 2 pi plus I. This we're gonna to integrate to x. This will be equal to x squared minus 3 cosine. Instead of say, if you say the integration of sine x, it is minus cosine, and then you have to say this 3 cosine x with respect from 3 to 2 pi. Then we are going to work out, evaluate, we replace where the x with the 3 and so part, then you get the final answer. So this will be equal to square of pi, you take x times 2 pi, 6 times 2 pi, then plus pi minus 18, then minus 3 cos, plus sine 3, then minus, yes, my, yeah, then bracket minus the imaginary, then x squared, it is 2 pi squared, then minus 3 cosine minus 9, then plus 3 cosine what? Cosine 3. Certain pi minus 18 sine 3 minus 3 cosine 3 bracket plus I imaginary part for a pi minus, so no, it is not the 0, pi squared plus 3 cosine 3. This is the final answer. Yeah, so that's how we work out the inner product with the given part in the complex, and we have the interval, then we work out with the appropriate formula. So thank you very much for watching this video. Bye now. I invite you to watch the next video, share, comments and so on, such that you can learn more about mathematics and can better help you. Thank you very much. May God bless you. subscribe on the Chris Kana Academy and share, by the way. I love you.